I wanted to do another example with you in case you saw something that looks like this, where you don't actually have maybe a slope, or maybe you don't, or excuse me, you don't have a y-intercept, or maybe you don't have a slope that's shown in your inequality. So we're just going to review how these look on the graph real quick. Over here, if there is no b, that means that it's 0. So we know that it's going to be going to the origin. So I can put a point right here. My slope is 2. So from there, I'm going up 2 over 1. And then I connect these up. And connect those. Okay? Remember, it does not, I like to just connect them, but instead of trying to do a dash, okay? But then you could just go back and go, okay, this is a dash line because it does not include that value. So I just do that. Now the next one has a y-intercept of -3. So that's right here. And there is no slope. And if the slope is 0, that's telling us that we have just a horizontal line here. Again, it doesn't include this value of -3 for y. So I'm just going to dash it. And this is something that you guys can easily do with your pencil as well. Just kind of erase, erase, erase in between. Now I'm looking at which way I'm going to shade. Y is less than this line. Here's my line. And y is less than. So I want the y values below this y-axis. I'm just going to shade this way. Make sure it goes all the way along your line that you're shading less than. And then my other one is greater than this value here, -3. Again, following the line. This is a horizontal line, so I'm just going to go straight up to show this. Now looking at this, there's one section that overlaps. Here we just have the pink, but as soon as we got to this general section here, it began to overlap. So then what I might do is just outline this area or shade it in darker or both to really make it clear that this is my solution to these inequalities. Okay, we're going to do a review as well on how we solve our inequalities. And remember, we have learned several methods, right, for solving our equations. But sometimes we need to rearrange to get our inequalities in the right form. So here's some examples of inequalities that do not have the y term isolated. So we're going to review how to do that and remembering what it means when we need to solve inequalities. There's a kind of a rule that was different, right, about inequalities versus equations. So let's look at the first one. We want to get y by itself. We're going to subtract 3y or 3x from both sides. -2y is less than -3x plus 10. Now we need to divide everything by -2. And we get y is greater than, right? Remember, we have to flip when we divide or multiply by a negative. When we're solving inequalities, that means that we're now flipping the order. We're doing the opposite. So we need to flip the symbol around. This becomes 3/2 x, positive, negative divided by negative, and then -5. So now we have rearranged our inequality to put it into sort of a y equals mx plus b form. And we remember that if we divide or multiply by a negative, at any time when solving this, we need to flip our symbol around. Okay? Let's do the next one. We're going to subtract 5x from both sides. We get negative 3y is less than or equal to negative 5x minus 15. We're going to divide everything by negative 3. And again, I've got a trigger going on that's like, okay, I need to flip this now because I'm dividing by a negative. So it's now going to be greater than or equal to 5/3 x plus 5. So reviewing these concepts is a really important strategy that's necessary before you can graph them accurately, and that way you can show the solution when you're dealing with two systems or a system of inequalities. So make sense of this, watch the video as much as you need to. If you still have questions, we'll go over it next time I see you in class. Happy learning.